Hello everyone, welcome back to my channel. My name is Dhruvi Patel. I am first year student of computer engineering at Swaminarayan University. Today I am going to solve LeetCode problem number 191, which is number of 1 bits. So in this problem I have given a number n and I have to find how many 1 bits are present in a number. So what is 1 bits? So after converting a given number into binary representation, how many 1 I am finding in the binary representation is called 1 bits. So now let's take example 1. So as you can see in example 1, I have given a number n equals to 11, and after converting 11 into binary representation, it becomes 1011, and uh, in the binary representation I am getting 1 is the 3, its count is 3, so here I have to return the 3 as the output. Now let's see the approach to solve this problem. So this is the approach. As you know, how we are converting our number into binary representation. So this is the small method from which we can convert our number to binary representation. So here I have to divide given number by 2 and check if it is given 1 or 0 as the remainder, and so I am storing 1 as 1 or 0 in the given means resultant string, and return the string as a representation or a binary representation of the number. So here when I am dividing by 2, it becomes 6 and I have a remainder 1. So I am adding 1 in the string. After that, when I am dividing 6 when I am dividing 6 by 2, so I get the remainder which is 0, and after that it becomes 3, and when I am dividing 3 by 2, so it gives the remainder 1, and at last I have remainder 1. So I have to add the numbers 1 and 0 from the last remainder I am getting. So the binary representation of the number becomes 1101. So here I have to return the numbers from the last, but when I am storing it in a string, here I am storing it like from the starting, like 1011. So in general case I have to reverse the string, but here I have to only count the ones. Here I have only count the one here only I have to count how many times the remainder 1 in the number. So I do not require to reverse the string which I have gained. So this is the approach to. So I am running the while loop until my number does not becomes to 0, and here I am dividing my number by 2 and checking if the number is means remainder is equals to 1. Then if it is equals to 1, then I am increment the count, and after that I am dividing the number by 2. That's why number becomes n equals to n by 2, and at last I am returning the count. Now let's doing the code for the better understanding. As I say, here I am taking int count to track how many ones are coming in the binary representation. Now I am running the while loop until my n becomes 0 for the greater than 0. Here I have to store the digit in the. Here I am taking digit for storing the remainder which I am getting by modulus of 10, doing the modulus of n by 2. After that I am checking if digit is equals to 1, then I am increment the count. After that I have to divide the number by 2. So it continue the loop and running. After that I have to at last return the count. So it gives the number of 1 bits appear in the binary representation of given number. Now let's check the code if it is working correctly or not. So as you can see, it passed all the 3 test cases. Now I have to check for the, now I can add custom test case from here. So here I am adding any number and check if it is working for any other number or not. So also it is passed for the other test case. Now I am checking the code by submitting. So also it is 100% correct for all the 598 test cases. Now I have a second approach to solve this problem. So second approach is I have to only run while loop, and directly I am storing the n equals to n and n minus 1. This is the condition. Now let's take example in which I am taking the number. Now let's take example in which I am taking number 13, and as according to this given condition I have to take the bitwise and for 13 and 12. So it gives the result as, so the binary representation of 13 becomes 1 1 0 1, and binary representation of 12 is 1 1 0 0. So after doing the bitwise AND operation on both these, I am getting the result is 1 1 0 0. So as you can see, it removes the last one from this and giving this result. So as long as I am running this while loop, and as long as I am running this condition, it removes the remove one from the given binary representation, and it runs, and this condition runs until how many ones I have in a given string. So here I have 3 1 in the given string. So this condition runs for 3 times, and uh, how how many times this condition runs, I am incrementing the count to track how many ones are in my uh, binary representation of number. So now let's doing the code for this. So here I have to take the count variable to store the to check how many times the while loop is running. Now I have to run the while loop until n. So whenever the n is any number and it does not equal to 0, it while loop is running. Now I have to check that condition which is n, and bitwise AND with the n minus 1. So this is the simple condition which gives all the which is true for all the results. Now I am increment the count because I have to track how many times the loop is running, and or how many times the condition is running. At last I have to return the count as the output. Now let's check if it is working or not. So as you can see, it pass all the test cases and also pass our custom test case. Now also check the code by submitting. So also it is pass all the test case, and successfully it is 100% correct. Now there is the difference between both the approaches, their time complexity and space complexity. So in the above approach, I have the time complexity and space complexity is big of 1, because it is runs for a constant time, because here I have a 32 bits, and it runs at least 32 times. So here both the time complexity is big of n, and here I do not require any space to store any value or anything. Here only I am using the variable which is count. So here time complexity is 1, and also in a second approach space complexity is big O of 1 because I am only using count, and time complexity becomes big O of k because it runs the loop runs k times because there are the number of ones, how many times the number of one in the binary representation, how many so it runs for the uh, now let's say the k is the number of one in the binary representation, therefore the loop runs for the k times. So this is the time complexity and space complexity comparison between both the approaches. So this is the solution. If you find this solution helpful, please like, share and subscribe my channel. Thank you.